Hello everyone! In today's lesson we will be studying logarithms and their properties. If you've ever felt that logs were confusing or abstract, don't worry. In this video we'll break them down step by step, starting from what logarithms mean, all the way up to their rules and properties with some examples. So first, let's start with a simple question here. If I ask you now, 4 to the power of what will be 16? Here you will simply answer me and say that it will be 4 power of 2 will be 16 because 4 by 4 will be 16. What if we make the question like this? 4 to the power of what will be 17? Here you won't be able to come up with an integer power on 4 to make it 17 because the power will not be a whole number here. So to find the power, you need to use logarithms. Here, later after the lesson, you will know that the power here should be something like this. Log 4 of 17, log base 4 of 17. And that will be, if you do it by calculator, 2.043. Which means you need to raise the number 4 to the power of 2.043 nearly to become 17. So to learn this and more, we will start with the definition and then we will have the rules. Here, as you see, the logarithmic statement, log base a of b equals x. That's equivalent to saying that this number a to the power of x gives you the inside, which is b. Again here, this is the base a. So the base a to the power of x will give you what's inside of the log, which is b. So as you see it here, a to the power of x equals b. Now we'll have many examples to understand this. Let's now start with this example here, log base 2 of 8. It's equal to what? So here, to answer this, now we need to know 2 to the power of what will become 8. 2 to the power of what will be 8. Or we need to multiply 2 by itself how many times to become 8? We know that 2 multiplied by itself 3 times, or 2 to the power of 3 will be 8. And that means here the answer will be 3. Again, check here. 2 to the power of 3 will give you what's inside, which is 8. As we said here in the introduction. Now another example. Log base 2 of 32. Here again, 2 to the power of what will be 32. Of course, you know that if we multiply 2 by itself 5 times, it will be 32. So 2 to the power of 5 will be 32, and the answer here will be 5 in the same way. Another example here, log base 2 of 2 equals what? Here we have the same numbers. That's why the answer will be immediately 1, because 2 to the power of 1 will give you the inside, which is 2. Another example, log base 2 of 1. Here, 2 to the power of what will become what? 1. We know that any base, like 2, to the power of 0 will be 1. So here the answer will be 0. 2 to the power of 0 will be 1. And later we'll know that log 1 is always 0 in any base. Another example here, log base 2 of 1 out of 4. Here, the number down here inside is a fraction smaller than 1. So 2 to the power of what will be 1 out of 4. Here, the power will be negative, and that will be negative 2. Because we know that 2 to the power of negative 2 will be 1 over 2 power of 2, which is 1 out of 4. That's why here the answer is negative 2. Now let's have examples with different bases. Log base 5 of 25, let's say. Here the answer will be 2 because 5 to the power of 2 will be 25. Last example here, log base square root of 3 of 3. So here now, square root of 3 to the power of what will become 3. Here, you know that when we raise square root of 3 to the power of 2, it will be 3 because we will cancel the 2 and the square root. So the power will be 2 and the answer here 2. Square root of 3 to the power of 2 will give you 3. Now let's move on to the properties. First, log 1 here, as we said before, log 1 with any base, appropriate base, like the base as we know in logarithms must be always bigger than 0 but not 1. This is by definition. This base a is always positive but not 1. So here log 1 is always 0 because a, no matter what a is, a to the power of 0 will be 1. So for example, log base 7 of 1 will be immediately 0. Now here log a of a will be 1 immediately because a to the power of 1 will give you a. So for example here log 13 here will be immediately 1. Here now we have two important rules. Log base a of x times y will be log of the first one plus log of the second one y. So we will turn the multiplication into addition of logs. To have examples on this, for example, we can say log base 4 of 16 times x. It can be broken down into log 4 16 plus log of x. Now here we know that log base 4 of 16 would be 2 because 4 power of 2 will be 16. So 2 plus log 4x. Another example here, we can say, we can also work on the same property but backward, like this. For example, let's say that we have log base 6 of 3 plus log base 6 of 12. Here, I have this side already addition. So using this property here, going backward, it can be written as log base 6 of 3 multiplied by 12, which is log base 6 of 36, and that will be 2. Because we know that 6 to the power of 2 will be 36. So now we will move on to the division property. Similar to this, but when we divide inside of the log, it will be log of the numerator minus log of the denominator. So here, to have examples on this, here we can write 2. So now here, to have examples on this, we can say log. So here we will have log base 3 of 81 divided by n, let's say. It will be log of the numerator 81 minus log of the denominator n, which will be, here log base 3 of 81 will be 4 because 3 to the power of 4 will be 81. So here we will have 4 minus log n as it is. Another example now, log base 5 of 50 minus log base 5 of 2. Here, according to this property, we can go backward and say it will be log of 50 divided by 2. So here we will have log base 5 of the numerator will be 50 divided by 2. So as we see here, log 50 over 2 will be log 50 minus log 2. This will be log base 5 of 25, and that will be 2, as we said before on the same example. Now we will move on to another important property. Here we have log base a of x to the power of m will be written as m multiplied by log base a of the expression x inside. In other words, m can go down in the front of the log and be multiplied by the whole logarithm. To understand this, here we will calculate log base 2 of 32. We calculated this before in this lesson and we said that it's 5. Here we'll do it in a different way. We can say 32 can be written as 2 to the power of 5. Now, according to the property, you can put the 5 down and then you will have 5 times log base 2 of 2, which will be 5 times 1, and that will be 5 again, because here log 2 is 1. Another example on this, here we can say log base 7 of, let's say, x to the power of 4 multiplied by z to the power of 2. First, since we have multiplication between x and z, we can break them down according to the property we said. Log base 7 of x to the 4th plus log base 7 of z to the power of 2. And now we'll drop the powers down in front of the log. So we will have 4 log x plus 2 log base 7 of z. Now here we will move on to the last property, which is an important one, the change of base. Sometimes in some questions, especially if we have paper 1 where we cannot use the calculator, we might need to change the base conveniently to an easier base. This is the formula. Log base a of x will be this. Let's say that you need to change the base of a to another convenient base b. So you can do it like this. Log base a x equals log base b of x divided by log base b of the old base a. Let's have an example. Log base 8 of 32. As you know that 8 doesn't go well with 32. We don't have a power on 8, a whole number power on 8 to make it 32. That's why we will change the base of 8 to an easier base, which is 2. So it will be now log base 2. So here the b, or the new base, will be 2. Log base 2 of 32 divided by log the same base 2, but for the old base, which is 8. Now log base 2 32 is 5, as we did many times today. Log base 2 8 will be also 3. That means log base 8 of 32 would be 5 over 3.